Hello and welcome to the video. Today we're going to talk about the unit circle, how to memorize it, and how to understand it. Really, memorizing the unit circle is tedious and involved, and there's no point in actually memorizing it because it's much easier to just understand what to do and then memorize the few values here and there. First thing I want to note here is that the unit circle is x squared plus y squared is equal to 1. This is the equation of the unit circle. Many people forget that the unit circle is actually embedded in the xy plane. We have a circle, radius 1, centered at the origin, 0, 0. Every point on the unit circle is actually a coordinate in the xy plane. And we can test whether a point is actually on the unit circle just by plugging in the x and the y value to this equation and determining if this equation actually holds true. For instance, if I suspected that 1/2 was on the unit circle, I can easily plug in 1/2 for x and 1/2 for y because my x coordinate is 1/2 and my y coordinate is 1/2. Now, what we would end up getting is 1/2 squared plus 1/2 squared, which is of course 1/4 plus 1/4, which is equal to 1/2 in totality. So since this sum is not equal to 1, but instead 1/2, it's not on the unit circle because it does not satisfy this equation, as we've seen before. Other points won't be on the unit circle that we actually use most often, but they are still points on the unit circle. For instance, 3/5, 4/5. This point is on the unit circle. I plug in 3/5 for x, I get 3/5 squared. 4/5 for y, I get 4/5 squared. And this ends up being 9 divided by 25 plus 16 divided by 25 when we square both of these. 9 plus 16 is 25, so we end up with 25 divided by 25, which is of course 1. Therefore, it satisfies this equation. Again, therefore this point is on the unit circle somewhere. Now, it's not at one of the common angles that we use and one of the common angles that we memorize, so we won't be going any farther into the point 3/4. Now, there's a few things that we should know already about the unit circle. First of all, we should know where pi is on the unit circle. Pi is the same thing as 180 degrees, the distance from the point 1, 0, all the way around the unit circle to the point -1, 0. This is pi radians. So, what that means is, because this distance is pi radians, we can say that this distance, halfway around pi, is 1/2 of pi. So this is 1/2 pi. Now, if you don't remember, we have 1/2 times pi, which is the same thing as pi over 2. And I will be writing most of my radian measures in this form just for the sake of understanding. Right. Now, the last thing I need to go over before we really get into understanding the unit circle and thus being able to memorize it, I want to note that the unit circle that we are accustomed to seeing is actually 2 unit circles on top of each other. One of the unit circles is the pi over 4s, and the other unit circle is the pi over 6s. I'm going to start with the pi over 4s because it's much easier. This is one of the unit circles. I do want to note that I split pi, this pi distance, into 4 equal regions. We have 1, 2, 3, 4, all equal. So we can say that this is actually 1/4 of pi because we split the distance pi into 4 regions. So we have 1/4 of pi. Now this point would then become 2/4 pi, and that should make sense because it reduces to 1/2 pi or pi over 2. This is 3/4 pi, 4/4 of course, which is equal to 1. This would be 5/4, This would be 6/4, and this is 7/4. Then coming all the way around to the 2 pi region, again, an entire circle is 2 pi radians. So this would be 8/4 pi, which is the same thing as 2 pi. We usually write 0 on top and 2 pi below to indicate that on top, if we're rotating counterclockwise, the positive radian measure. If we've rotated 0 radians, we're still here. If we rotated 2 pi radians, that means we went 1 full circle, but we're still ending in the same point. In the coming sections, we'll talk about this a little bit more. But for right now, I want to talk about why we went over 6.1 and 6.2 before we get into Chapter 5. That's because Chapter 5 deals with the unit circle, but Chapter 6 deals with triangle trigonometry. In order to find the coordinates of the point in the xy plane, we draw a triangle, and then we just determine what the x and the y values are. Our x value will be this distance, and our y value will be this distance. In order to plot a point in the unit circle, remember, you move horizontally an x distance and vertically a y distance. So if I wanted to plot this point, I would need the coordinates, which we're going to find in a second. I would move over the x amount and up the y amount. This angle is pi over 4 radians, or 45 degrees. That means that our x and our y are going to be the same length. As we talked about in Chapter 6 already, we derived this special triangle from a square with side length 1. In this case, we're not going to have side length 1 because, of course, 1 squared plus 1 squared is 2, not equal to 1. So the point 1, 1 is not on the unit circle. However, we do know that this side and this side will be the same. So what I want to do is I want to figure out what this side is equal to. First, I need to note that the radius is, of course, 1. Any radius is 1, so every time we draw a point emanating from the center of the circle to the edge of the circle, that length is 1 unit. So the hypotenuse on this triangle is 1. Now, you need to remember what trig ratio draws an equation with this angle, the opposite side, and the hypotenuse. And if you remember, that's going to be sine. Let me call this side y because it's our vertical distance. So sine of this angle, 45 degrees, or pi over 4, same thing, is going to equal opposite over hypotenuse, y divided by 1, or just y, because y divided by 1 is just y. Now, so what that means is, if we know what the sine of 45 degrees is, then we know what y is, because that's exactly what y is. And we do know what the sine of 45 degrees is. It's root 2 over 2. So we end up with y equaling root 2 divided by 2. Again, we found this in Chapter 6. In a similar fashion, we can figure out what x is in actually a couple of ways. If I know what my y value is, I can plug it into this equation, solve for x, or I can do the same thing that I did with sine and say, what trig ratio draws an equation between this angle, the adjacent side, and the hypotenuse? And that's cosine. So cosine of 45 degrees will equal the adjacent side divided by the hypotenuse, which is x divided by 1, or just x. And we know what cosine of 45 degrees is, again, from Chapter 6, so we get root 2 over 2. So what that means is that our x and our y value are both root 2 over 2 for this coordinate. So the terminal point is root 2 over 2, root 2 over 2. We already know what this point is. It's just 0, 1 because we're going straight up. We're not moving horizontally at all, so our x distance is 0. Our y distance is 1. So we know what this point is. We can find this vertical distance and horizontal distance very easily. It's actually just going to be this point reflected about the y-axis. So this point will actually have the same y value as this point. Notice that the vertical distance here is going to equal the vertical distance here. So if I draw a triangle like I did before, I end up with this y distance, which is equal to this distance here. So I already know what my y value is for this point. It's going to be root 2 over 2, because it's the same y value here. Now all I need to do is find the x value. It's actually going to be the same x value except negative, because we're moving to the left and not to the right. So we end up with the same exact x value, but it's negative instead. So we have a negative root 2 over 2. This point is, of course, negative 1, 0. And if we continue here, we can see that the x value will be the same between these 2 points. The x value is the same because we're moving this distance to go to this point and the same distance to go to this point. So the x value is the same. So we know that this point will have a negative root 2 over 2 for the x coordinate, and our y coordinate is going to be the exact same y coordinate as these two, except negative because we're moving down instead of up. So notice here we have a positive y value because we go above the x-axis. Here we have a negative y value because we're moving below the x-axis. So we end up with negative root 2 over 2 here. This point is, of course, 0, negative 1. And then this point, as you can probably figure out, because it has the same x value as this point, we know that the x value is positive root 2 over 2. Now we, again, are moving down instead of up, so we have a negative y value. It's actually exactly this y value, but negative. So we end up with all of these points on the unit circle. So any pi over 4 angle, any angle where we have some number of pi's divided by 4 that's irreducible, we'll have a coordinate, root 2 over 2, root 2 over 2, with varying signs, whether it's positive or negative. So really all you need to do when you see that you have an angle, something pi divided by 4, you know it's going to be root 2 over 2, root 2 over 2, and then you just need to apply the negative sign as necessary. So if you're in the first quadrant, your x is positive, y is positive. If you're in the second quadrant, your x is negative, but your y is positive. If you're in the third quadrant, both x and y are negative. And if you're in the fourth quadrant, your x is positive, but your y is negative. And that's this one. All right, the next part of this video, I want to talk about the second unit circle, the one that we haven't seen yet. Now, the second unit circle is going to be the pi over 6's. So we have, again, pi here, but this time we have these lines. This time we divide pi, this distance pi, into 6 equal parts. So this is 1/6 of pi. This is the second, third, fourth, fifth, and sixth 6 of pi. So here, this is 1/6 pi, 2/6 pi, 3/6 pi, which is the same thing as 1/2 pi or pi over 2, would be 4/6, 5/6 pi, and 6/6 pi. And of course, we just continue on, 7/6, 8/6, 9/6, which reduces to 3 pi over 2, 10/6 pi, and 11 over 6 pi. Of course, this one is 12 over 6, or 2 pi. And again, we have a 0 on top. So this is how you find the radian measure of every angle. If you were doing degrees, you just add 30 degrees each time. 30, 60, 90, 120, 150, 180, and so on. What we're going to do next is we're going to find the coordinates of each of these points, which we also call terminal points. Let's figure out the terminal point at pi over 6 first, and then we'll move on to the terminal point at pi over 3. Notice that 2 pi over 6 reduces to pi over 3. 4 pi over 6 reduces to 2 pi over 3. This is 4 pi over 3 and 5 pi over 3. We get each of these reductions. So we're going to go about this in the exact same way that we went about the other unit circle. We have our y value here and our x value here. I also want to note again that any point emanating from the center of the circle to the edge of the circle is length 1 because we have a circle of radius 1. So we have our angle here, pi over 6. Sine of pi over 6 is going to be opposite over hypotenuse. So if we call this our y value and this our x value, sine of this angle will be y divided by 1. So sine of pi over 6 is equal to y divided by 1, or just y. Now this is important because we talked about this in chapter 6, where we derived the ratio for sine and cosine for these particular angles, pi over 6 and pi over 3. Now if you remember, sine of pi over 6 is actually 1/2. And if we're looking for cosine, which would give us the x value, because cosine of this angle will be the adjacent side of the triangle divided by the hypotenuse, we would have cosine of pi over 6 is equal to x. Now cosine of pi over 6 is root 3 over 2. Again, we derived that in chapter 6. If we know this terminal point, we can find this one, and this one. I'll go over that in a second, but I want to find this terminal point first. So again, we draw a vertical line, make a right triangle. Now we have this angle here. We'll do this one in red, which is pi over 3. Again, the radius is 1. Our y distance is this vertical line, and our x distance is this horizontal line. Again, sine of pi over 3 is going to be opposite over hypotenuse. So y divided by 1, or just y. And cosine of pi over 3 can be adjacent over hypotenuse, or just x. So we end up with y being root 3 over 2, and x being 1/2. Again, derived in chapter 6. So we know that this coordinate is going to be exactly 1/2 root 3 over 2. So now I made the claim that I could find this coordinate, this coordinate, this coordinate, and this coordinate just by using these two coordinates here. And we do it exactly how we did it before. We draw a horizontal line here. We notice that the y value is the same because we go up the same distance, this y distance. So we know that the y value of this point is 1/2. Now, in order to be on the circle, it's going to have some symmetry about it. So we have 1/2 for our y, which means our x is going to have a value of root 3 over 2, except we're moving to the left, so we have a negative x value now. So negative root 3 over 2. We do a similar thing. We can see that the x value for this coordinate and this coordinate are going to be the same, negative root 3 over 2. And again, symmetry would say that the y value is 1/2, except we're moving down, therefore it's negative 1/2. So we have negative root 3 over 2, negative 1/2 for our coordinate for this point. Now this last one is the easiest. We could draw a horizontal line here to see that the y value is the same, and a vertical line here to see that the x value is the same. So we end up with this coordinate having the same x value as this point and the same y value as this point. So root 3 over 2, negative 1/2. We could do this with the pi's over 3 as well. I'm going to show you this one more time. We have the same y value. Therefore, the y value associated with 2 pi over 3 is the same as the y value associated with pi over 3, namely root 3 over 2. So this point has the coordinate negative 1/2 root 3 over 2. We can draw a vertical line here to show that we have the same exact x coordinate. So that means that this point at 4 pi over 3 is going to have an x coordinate negative 1/2. Again, symmetry would say that we have our y value as root 3 over 2, except we're moving down, so we know that it's negative. So we have negative root 3 over 2 here for our y value. And the last point, of course, this one will have the same x value as this point, and the same y value as this point. So we end up with the point 1/2 negative root 3 over 2. Now this is how we get the coordinates for every single point on the unit circle that we usually memorize. Okay, we're at the end of the video, so I want to show you the last thing about this unit circle, specifically this. So this is what the unit circle looks like. Pi over 6, pi over 4, pi over 3, pi over 2. And we keep going around as I showed you before. But there are only 5 values that are parts of the coordinates of each point on this unit circle. We have 1 and 0, which are paired together. We have root 3 over 2 and 1/2, which are also paired together, and then root 2 over 2, which is paired with itself. All of the coordinates will be some form of these pairs, with negatives where we need them. So again, first quadrant, x is positive, y is positive. Second quadrant, x is negative, y is positive. Third quadrant, x is negative, y is negative. And fourth quadrant, x is positive, y is negative. I also want to make a note here that the hardest points, the hardest coordinates to remember are always this pair here, root 3 over 2 and 1/2, always. Now, a lot of students mess up with which of these two values is larger. So I'm going to ask you, is root 3 over 2 larger than 1/2 or smaller than 1/2? And take a second to think about it. But if we do this, then it becomes obvious. Root 3 is bigger than root 1, therefore root 3 over 2 is bigger than root 1 over 2. But remember, the square root of 1 is exactly 1. So square root of 1 is the same thing as 1. So we end up with just 1/2 here. So we know that root 3 over 2 is actually bigger than 1/2. So when we have our triangle here, we have a long side x and a short side y. What that means is that the x value is going to be root 3 over 2. The y value is 1/2 because 1/2 is smaller than root 3 over 2. If we look at this angle instead, at pi over 3, then we end up with the short side is x, the long side is y. So the long side again, y this time, is root 3 over 2. The short side is 1/2, which would be x in this case. So if you can remember these 4 points, and you remember that root 3 over 2 is larger than 1/2, it should be pretty easy to fill in a blank unit circle. Now, throughout the semester, you do need to memorize the unit circle. It's very, very important. You should test yourself occasionally throughout the semester to make sure that you remember it. But that's going to be it for today. I will see you all in the next lecture.